Hello and welcome to another session in IBDP MAI HLSL course. And in this session, we are going to cover SL 1.4, which is Financial Applications of Geometric Sequence and Series. In this, we are going to discuss compound interest and annual depreciation, how to find the final amount if compounding is done quarterly, monthly, yearly, okay, and also the effect if there is a annual depreciation, how to find the value of an object after n number of years. Okay, so let me tell you something about the compounding thing. As you all are aware with final amount of some investment which is made, like P is the principal amount that we paid, right, is given by the final amount after n number of years is given by 1 P times 1 plus R over 100 raised to the n, where this P is the principal amount or our investment that we are making, one time payment you can say. R is the rate of interest here, which is compounded annually. N is the number of years. Okay, R is rate and P is the principal amount. So we will get this much amount after n number of years. But if there is an object and inflation rate is applicable on that, let's say R is the inflation rate. So the value of that object gets decreased with the time. Okay, so in that case, the depreciated value, okay, depreciated value of that object after n number of years will be P times, or our initial value of the object, times 1 plus, instead of plus there will be a negative sign here, 1 minus, because value is decreasing, by R interest rate whole raised to the power n. Okay, R is the inflation rate, so value gets decreased by this, and this is going to be the final value of the object after n number of years. Okay, in any question, if they gives you the amount, let's say amount is 1000 final amount and your initial investment was, let's say, 250. So what should be the rate of interest so that the 250 dollar becomes $1000, right, after, let's say, 20 years. So in that case you are going to solve for R. Okay, so after 20 years, you have to solve this for R. So what you can do is you can use your GDC numerical solver function in that to get your answer. Okay, and there are built-in functions packages in your calculator also that you can use directly. Okay, so we will discuss about this built-in financial packages in the SL 1.7, right? Okay. Now, next thing is, what will be the effect if the compounding is not done yearly, if it is half yearly or the quarterly or the monthly? So compounding is done quarterly, monthly or half yearly. In that case, we have to make some changes in the expression. So let's say FV is the future value or PV is the present value. R is the rate of interest, okay, and it is compounded K times in a year. In that case, the final amount is given by present value times 1 plus R over 100 times K, okay, raised to the power K times N, where K is representing how many times in a year compounding is done, right? So K is the number of compounding periods per year, FV is the future value, PV is the present value, N is the number of years, R is the rate of interest annually. Okay, so you can make the changes in your formula to get the final amount after that many years when compounded is done k times in a year. Okay, or you can use the numerical solver if they ask for r value, or if they ask for n value, or if they ask for present value and all. Okay, so let's solve a question here. It says euros 1000 is invested in an account paying the compound interest of 6%. Compounding is there, but in the first part it is annual, then second quarterly, and then monthly, and we know how it's going to affect our answer. To calculate the amount of the money in after 10 years, so that's the n value, number of years 10, r is what, 6%, so I can also write it as 0.06 divided by 100. Okay, $1000, that's my present worth, or the present value. Now let's find the final or the future value. So after say, 10 number of years, it will become, the future value will be present value, which is 1000, right, times 1 plus 0.06 whole raised to the power 10 simply. So that's going to be my answer. Comes out as 1790.85. So you can round off your answer and say 1791 euros. Now in the second part, if it is compounded quarterly, it means 4 times in a year. So that's the K value. Okay. So this time, if you use the K as 4 for the second part, you can get your answer as, the future value will be given by future value 1000 times 1 plus 0.06 divided by 4 and raised to the power 10 times 4. This is going to be the expression for the quarterly part. And that gives me the answer as 1814.02. Now for monthly, you are getting the interest compounded in every month, means total 12 times in a year. So K is 12 for this. So simply replace the K by 12 and we will get our answer as 1819. And you can see the effect. If the compounding is done yearly only, we are getting this amount for quarterly and monthly, right? If the compounding is done monthly, we are getting more amount, okay, as compared to the previous. So in this way, we can find the final amount, or if the final amount is given and they are asking for how many, let's say, they says find how many years it will take to double the amount if it is compounded yearly, annually only. So in that case, what you can do, take final amount as 2000, right? Final amount as 2000, that should be equals to the initial investment 1000 times 1 plus, as I said, annually compounded with the same interest rate 6% raised to the power n. Now you can use your numerical solver in calculator, or you can use the graphing calculator, draw the graph. We already did this in the previous session, how to find the point of intersection and solve for the value of n. Okay. So in the comment box, please tell me what is the value of n that you are getting correct up to 3 significant figures. Okay. Next one. Next question is, Stephen invests $4,350 in a saving scheme paying simple interest at 1.7 per annum. In case of simple interest, the amount or the simple interest value, only the interest value is given by present value times rate of interest times total number of years, or the time you can say, whole divided by 100. That is the simple interest. And in order to get the amount, we have to add the simple interest to the principal value. So this is going to be the amount, right? That is for simple interest, right? In simple interest, we get the same amount after every year. Okay, not on the amount in the account the last year. No, simple interest is always applied on the initial investment only. Okay, so it says Chimdi invests the same amount, 4,350, in a different scheme that gives us annual rate of 1.15%, but it is compounded. Compounding is there quarterly. Okay. Now they both invest their money for 7 years. So we already have the n value. The time is 7 years. The present value for both is $4,350. But R is say different for both, and also the schemes are different for both. Okay, so let's find. It says Stephen predicts that his investment will be worth more. Determine if Stephen is correct or not. So what we have to do? We have to find the final amount after 7 years in both the schemes. That's it. First is according to simple interest. Second is according to compounding, and compounding is done quarterly. So K is 4 already. Okay, so let's find this. So Steven's investment will be equals to the principal amount 4,350 plus the interest calculated in 7 years. That comes out as 4,867.65. Now let's find the Chimdi's uh, investment value after 7 years using the compounding. So we have the principal 4350 times 1 plus 1. 15 divided by 4 because k is 4 over here times 100 raised to the power 7 times 4. And using the calculator, we got the value as this one. So what do you think? Who is getting more? Yes, Stephen. Correct? Stephen's investment is worth more as compared to Chinri's. So Stephen is correct. That's the answer. Okay. So in this session, we have covered whatever is required for S1.4 topic, which is finding the future value, right? If the compounding is done quarterly, yearly, annually, right? Based on that. And also calculating the interest rate or number of years if the other parameters are already given. So you can use either GDC or built-in functions are also there that we will discuss in 1.7. You can watch that video. And also you can draw the graphs or you can use the numerical solver. Okay. If you need any other help, feel free to ask me. You can write down in the comment box. I will explain everything. Okay. Calculate the value of the good suffering from the depreciation. I already explained the depreciation as well as inflation thing. Okay. So that's it for this session. Thank you for watching this. See you in the next part. Keep watching, keep learning.